Hello everyone, this is Poorani. In the previous video, we saw the first 5 exercise problems. Now we will do the next 5 problems, which is from 6 to 10. This is from class 9 NCERT textbook, chapter 7, motion. So this is the 6th problem. It says figure below shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following questions. So first thing we have to do is read this graph carefully. We have to know what is given in the graph. So as we see, we have distance in the y-axis and time along the x-axis. Time is given in hours, distance in kilometers. So from these given values, we have to answer the questions given below. First question is, which of the 3 is traveling the fastest? So to find which is fast, we should know the speed. So what do we know? We know speed is equal to distance by time. In the graph, we see distance is along the y-axis and time is along the x-axis. So we get speed to be y by x, which is nothing but the slope of each of the line will give us the speed of the particular object. So when we see from the graph, we find that the slope of B is the greatest. So this implies that B is the fastest. So the next question is, are all 3 ever at the same point on the road? For this, all the 3 lines should meet at one point. So that is what it means when all 3 are at the same point. So we see from the graph that no 2 intersecting lines will intersect more than once. In the graph, we see there are 3 lines. Each line intersects each other line and we see 3 unique points forming a triangle. You see a triangle here. At this point, we have a triangle. Since there are 3 unique points, the 3 lines will not be intersecting at one point in any future. Hence, A, B and C will never meet at one unique point. So they will never be at the same point on the road. So for this question, the answer is no. The C question is, how far has C travelled when B passes A? First one, we have to see where is B passing A. The line B is going here and the line A is here. So this is the point where B is meeting A. So from when B passes A, this is the point. What we have to find out is how far has C travelled. So for this again we have to know few things from the graph. First thing is we have to find the distance. So we have to know the y-axis. So in y-axis from 0 to this point, 1 unit say, we have 7 lines. So this 0 to 4 has 7 lines. So one graph unit will be 4 divided by 7 kilometers. Meaning this one, from 0 to this one line, the object will be traveling 4 by 7 kilometers. So C at the initial point or at time 0, C has already travelled some distance. It is not at the origin. So it has travelled this distance already. So say 1, 2, 3, 4. 4. So the initial distance of C at the time 0 is equal to 4 by 7 into 4, because there are 4 lines there. So we have 16 by 7 kilometers. So this is the initial distance of C. So at this time 0, C has travelled this distance. So this is 16 by 7 kilometers. So what we have to find out now is the distance of C at this point. So which is from the origin it is 8 kilometers, say. From the origin the graph, we see this, we see it is at this point B is crossing A. So from the origin it is 8 kilometers. But what we have to do is we have to subtract this initial distance, which is 16 by 7. So the actual distance C has travelled when B passes A is, actual distance will be this 8 minus the initial distance 16 by 7, which comes approximately to be 5.71 kilometer. So answer for this one is 5.71 kilometer. So what is the next question? How far has B travelled by the time it passes C? Where is the point where B passes C? This is B line and this is C line. So this is the point. This is the point B has so we see the point at this point we have to find out I'm sorry, there is some technical problem going on. Okay, I will okay. So this point, at this point we have to find out the distance B has travelled. So for D, what we say is, this is how many units. When we count this thing, we have 9 units, 9 lines, say 9 units. So when it is 9 units, what we have to do? Each unit is 4 by 7 kilometers. So 4 by 7 into 9 will give us the distance of B. So this works out approximately to be 5.14 kilometers. So the answer for this is 5.14 kilometers. So okay, so this is how we do the graphical problems. This is the 7th question. The question reads, a ball is gently dropped from a height of 20 meters. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? So we have two questions here. We have to find the final velocity v and the time it strikes the ground. So when this is a example of a free falling object. So when a body is freely falling, it is acted upon by the gravity of earth, which is approximated to 10 meter per second square. This is the acceleration due to gravity of earth. So what are the information we have? The distance, yes, or the height is 20 meters and the acceleration due to gravity is 10 meter per second square. So from these two information we have to find out the velocity and the time. So how do we find velocity? 2a v square minus u square is equal to 2a, yes. So here what do we have? U is equal to 0 because the object is dropped. So there is no initial velocity for the object. So v square is equal to 2 into 10 into s is 20. So what do we have? 400. V square is equal to 400. V is equal to plus or minus root of 400, which is 20 meter per second. The velocity is, final velocity is 20 meter per second. So the next part of the question is we have to find t. So for t, what do we have? Which formula we will use is v minus u by t is equal to a. We have to find t. So t is equal to v minus u by a. So we found out v just now. V minus 0 by a is 10. So we have 20 by 10, which is 2 seconds. The time the ball takes to reach the ground is 2 seconds. So this is the 7th question. We'll go to the 8th question. 8th question is again a graphical question. So this graph is a speed time graph for a car. So this, what do we, again we have to note down whatever is given in the graph. So we have speed in the x-axis, which is in meter per second, and time in the y-axis, which is in, speed in the y-axis, which is in meter per second, and time in the x-axis, which is in seconds. So the first question is, find how far does the car travel in the first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during the period. So we are asked to, this 4 seconds, we have to shade this area. Yes, this will be the distance traveled. We know distance is equal to speed into time. What do we have here? We have approximately a triangle here. If you see, this can be approximated to be a triangle. So for a right angle triangle, the area, this area is the distance traveled by the car. So the area of the triangle is will be half into base into height. So for here, this is the base from 0 to 4. So half into 4 into the height is here, which is 6. You see it here, this 6. So this will be the distance. So half into 4 into 6, we have 12 meters, which is the distance traveled by the car in the first 4 seconds. So the next part is, which part of the graph represents uniform motion of the car. What do we mean by uniform motion? We mean that the speed does not change. So this part of the graph from 6 seconds to 10 seconds, this part of the graph, the speed is uniform. So this straight line, when we have, the speed is approximately 7 meter per second. If you see, this speed is approximately 7 meter per second, and this is the place where the graph represents uniform motion. So from time 6 seconds to 10 seconds, speed is constant. So this implies uniform motion. Okay, this is the 8th question. So the 9th question is, we have 3 questions here. We have to find out examples for these 3 possibilities. These 3, what do we call? these three events or these three conditions. Okay, so the first one says an object with a constant acceleration but with zero velocity. So can this really happen? So for this we have to think of situations where this can be possible. So we already spoke about throwing of ball, throwing of an object or throwing of a stone or something. When we throw it against the gravity, what happens is it goes to a maximum height. So at this maximum height, the velocity is 0. But there is constant acceleration, which is the acceleration due to gravity of the earth. So the A question is possible. And the sorry, and the example for this is stone thrown upwards at its maximum height. At this point we have constant acceleration, which is acceleration due to gravity, and zero velocity. So the next condition is an object moving with an acceleration but with uniform speed. For this we have to understand what is speed and what is acceleration. Speed does not have direction. Velocity has direction, acceleration has direction. So when there is a circular motion, so this condition is also possible. And the example for this is circular motion. When there is a circular motion, what do we have is, say an object is moving in this circle. Say this is an object. So it has a constant speed. But when you see, the velocity keeps changing direction. So when there is a change in the velocity, there is change in acceleration. So there is an acceleration. When there is a change in the velocity, there is acceleration. So but the speed here is uniform. So this again is possible. So a stone or any object which is moving in a circle will have a acceleration but travels with uniform speed. What is the C question? An object moving in a certain direction with an acceleration in the perpendicular direction. So again, for this also, the example we have is a circular motion. Circular, as we see from the above picture, what we have here is an object is moving in a particular direction, say it is moving in this circular direction, and at each point what we have is the acceleration is perpendicular to the direction of the motion. See, the object is moving in this circular direction, and at each point we have the acceleration to be perpendicular to the direction of motion. So all these three conditions are possible, and we have given the example for each. So we will go to the 10th question. The 10th question is, an artificial satellite is moving in a circular orbit of radius 42,250 kilometers. Calculate its speed if it takes 24 hours to revolve around the earth. So what are the information we have? We have the radius to be 42,250 kilometers. So and the time is 24 hours. So we have to find out the distance. The distance travelled by the artificial satellite will be the circumference of the circle. Circumference. which is equal to 2 pi r, which is equal to 2 into 22 by 7 into r is the radius, which is 42,250. Then the time is 24 hours, which is equal to 24 into 3600 seconds. So we have to find the speed. Speed is equal to distance by time. So we have 2 into 22 by 7 into 42,250 divided by 24 into 3600. So this will work out to be 1859000 divided by 604800. So this I have already calculated. So this will be the numerator and this will be the denominator. So when we divide, we have 3.09, which is approximated kilometer per second. So this is, if we should have it in meter per second, we have 3090 meter per second. This will be the speed of the artificial satellite. So with this, we finish this chapter. Hope you all understood the problems. In case you have any doubts, please contact me in the WhatsApp number given in the description box. Thanks for watching. Happy learning.